Welcome DKWP 小工 aboard. Your learning journey starts now. Ever felt math was just a bunch of abstract nonsense? You're not alone. Even the brilliant Carl Jung had a painful relationship with it as a kid. But his story isn't just about fear, it's a profound question about meaning. So, what exactly was Jung's beef with math? It wasn't just bad grades. He was fundamentally confused. What are numbers? Are they invented or discovered? Concrete or abstract? This ontological confusion was huge. Then came the syntax versus semantics clash. The teacher says A equals B. To Jung, A and B were clearly different symbols, so how could they be equal? It felt like a lie, a scam. Same with parallel lines never meeting, then suddenly intersecting at infinity. That sounded like verbal trickery. Jung wasn't just confused, he was morally indignant. He called it intellectual morality. Thought must be honest, even in math. He refused to accept rules that seemed to betray meaning. This wasn't laziness, it was a deep demand for authenticity in knowledge. Fast forward decades. The young man who railed against A equals B becomes the elder sage who sees numbers differently. Jung's view transforms dramatically. He realizes numbers aren't just tools, they're archetypes of order, fundamental patterns in our collective unconscious. They help us impose structure on chaos. He even calls them psychoid, existing both in our minds and in the physical world, bridging the gap between subjectivity and objectivity. Think about it. Numbers pop up in dreams, symbolizing wholeness, duality, balance, totality. Jung saw this as the unconscious guiding us towards psychological integration. And in his synchronicity theory, numbers become potential codes, linking inner states and external events. Numbers evolve from a source of confusion to keys unlocking the mystery of mind and matter. Now, let's jump into the modern world. Yukong Duan proposes DIKWP semantic mathematics. Sounds fancy, right? It's basically an attempt to put meaning back into the heart of math, especially for AI. Think of it like building a pyramid. Data at the bottom, then information, knowledge, wisdom, and crucially, purpose at the top. This isn't just jargon. It introduces semantic consistency axioms. These axioms ensure that when you use an equal sign, like A is equivalent to B, it's because A and B truly belong to the same semantic category, not just because some rule says so. It tackles the very problem Jung had with A equals B. It also builds a four-space architecture: concept space, cognitive space, semantic space, and consciousness space. This whole setup aims to create AI that doesn't just calculate, but reasons with purpose, checks its own meaning, and aligns its actions with its goals. It's about making machines think more like humans, perhaps? So, what happens when we put Zhong and Duan side by side? Some fascinating echoes emerge. Both fundamentally reject mathematics as a mere game of symbols, detached from reality and meaning. Jung's gut feeling about A equals B, needing a semantic basis, finds formal expression in DIKWP's semantic equivalence axioms. Jung saw numbers as a bridge between mind and matter. Duan uses semantics as the bridge for AI. Jung talked about individuation, the drive towards becoming oneself, a kind of purpose. DIKWP explicitly adds a purpose layer to guide AI's thinking. Jung provided the philosophical depth, the why of meaning. Duan offers the engineering framework, the how. It's not a perfect match, but a powerful synergy. Jung's critique paved the way for Duan's construction.